Hey guys, welcome to the new NFR playlist video. Today we would be discussing on security. At a high level, we all know about the security, authentication, authorization, encryption and stuff like that. But as a system designer, what all different layers are there? First, we need to understand it structurally. Like, hey, these are the different layers that actually needs to be protected when we are designing a system. Second is how we should protect that. So those are the things from a system designing point of view I would be discussing today in this video. So what is the agenda of this video? In this video, we would be discussing on firstly, what to protect. Then second, why it is important for us to protect that, the layers and why we would be protecting that. Then the third thing is currently what mistakes generally an engineers are making or designers are making when they are protecting that particular system. And the final thing is how we should protect it. And like other videos, we would be taking an example. So we would be taking an example of UIDAI system and a banking system. So assume UIDAI, it is a system where Aadhaar card is issued. So Aadhaar card is nothing but a unique individual identity that is assigned to every Indian. And it contains a lot of secure information, biometric information, which is today's gold mine you can consider. Now assume a use case where a UIDAI system is not secure enough. You are giving your thumb impression, and now your thumb impression is getting stolen and it is being used for any illegal or any terrorist activity or any kind of a banking fraud. Then in that case, who would be responsible? So assume like you are building a UIDAI system, or assume you are using that system and that system is not secure enough. Will you be able to trust it, no matter how performant it is, no matter how available or reliable that system is? But if that system is not secure, then everything is waste. Customer is not going to use that system because no one trusts that system. That is the issue. Then the second thing is the banking system. Banking, we all know, like it is very much important. The financial transactions takes place in that. In a banking system, you are depositing and you are withdrawing, you are doing a financial transaction. After that transaction, you are seeing like, hey, my account balance is 1000 rupees. But after one day, you are seeing like, hey, your account balance has been reduced to 500. So now, even though you haven't made any financial transaction, but still your account balance got reduced. Now, because now there is this data integrity issue, like, okay, your data was not secured enough, someone has illegal access to it, unauthorized user can access it, and because of that they entered into your system and they made the changes. So like this, I can give you thousands of an example with thousands of different systems. What I just wanted to highlight is how important a system security is in a system. And as a designer, be it any domain, you are designing a system, if your system is not secure enough, then no matter even if you are solving the functional requirement, but no one is going to use your system. There is no trust customer would have in your system. So security plays that vital role. So let's start. So first we would be discussing on what to protect. So there are four major components that needs to be protected. One is data. Now data can be at two levels. So first is data can be in transit, and then second, data is at a storage level. So data is very much important because data is the one that needs to be protected at any cost. If a customer is transiting the data, like let's say via an HTTP request or event or whatever it is, if he is transiting, if he is sending your data and in between only the data gets hacked, it is like a man in the middle attack, or someone spoofs the data and they perform any kind of a mischievous activities, then the data is compromised. Second, once the data you have collected, you have stored it in your system, then again there is your responsibility, and it is completely your responsibility to ensure the data that you have given, customer has given to you, is protected. Then the next thing that we need to protect is application, because application is the one who will be at the end of the day using the data. Even if you are protecting the data but you have left your application unprotected or unsecured, then anyone can access your application. It can be unauthenticated, unauthorized user, it can be any hacker. He can access your system and he can perform any activities which is going to spoil your application, spoil your data, bring down your application, whatever can happen. So for someone to access your data, application is the medium, and if you are protecting the data, then it is your responsibility to protect the application as well. Then the third thing that comes into the play is infra. Infra is the base. It is the platform on which the application, the data, everything is hosted. If let's say you have protected your infra, you have protected your data, but if you have forgotten to protect your infrastructure, now when we are saying protection of your infrastructure, it means like, okay, someone can giving you, like let's say, more requests than your system can handle, then in that case your system is coming down. Or someone can applying any kind of a brute force attacks to crack the this thing, basically like your password, if someone is trying to do that thing, or someone is hijacking your system, providing an SQL injections or network, finally like everything that is going to happen between you and the customer, it is going to be via network. Like an example I've given you, ingress, egress, protecting like how the requests are coming to you from the public internet, internal communication using private internet or private subnet or inside the VPC, that we need to ensure the connectivity and the security. All those things are there that we need to protect. So data, application, infra and network, these are the 4 important layers that you need to focus on when you are protecting your system, when you are focusing on the security part of it. Next, we would be discussing on why to protect this information. So the main important crux, and not only about these 4 different layers, but why do you need to ensure like your system is secure enough and you are following this non-functional requirement of security stringently, like what is the purpose of that? So the 3 main reason is confidentiality, integrity and availability. Confidentiality, it means like okay, customer is confident on your system to share the data with you. If he is not confident, he will not share the data. So he is confident like, hey, whatever data I am protecting, I am giving to this particular system, that data is protected. Let's say if I am giving my biometric information to a UIDI system, I am confident like, okay, my iris scans, my facial scans, my biometric, my thumb impression, everything is safe and secure. It is completely protected. That's the reason. So that is the confidentiality that customer should have on your system. Next is data integrity. If I am giving you certain data, after a course of period, if I am not performing any operation, then that data should be the way it is when I have provided to you. For an example, today I did a banking transaction and my account was having 10,000 rupees, let's say. Even if I am not touching my bank account for let's say 1 month or 3 months, after 3 months if I am coming and I am looking into it, my account balance should be 10,000 only. It should not happen like my banking amount has been changed, or else any new transactions has been added, subtracted, whatever. So my statement, my bank balance, my account, everything the way it was, it should be the way it is after 3 months or 6 months. That is the data integrity. Like the data that I provided at the start, the data should be the same. For example, if I am giving my phone number, I am giving my address, and now in that case, unless and until I am explicitly coming and changing, that information should not be changed. That is what the data integrity is. And then finally the availability is. The availability is like, okay, my data should be as secure as possible, and whenever I want, that data should be available to me. If my data is not available to me, then like I completely don't trust your system. So that's the important, like confidentiality, integrity and availability. These are the 3 things. That is what we need to build so that like a customer should share their data, should use our system safely and securely. Now, coming to the third part, mistakes that generally we are making, or majority of our systems are there that are making while considering or while protecting these particular layers. We would be discussing those now. So these are the mistakes. So let's go one by one. So no stringent authentication. Today almost every system is authenticated. They have a basic authentication, at least the username and the password, or else at least one level bigger, okay, sending a mobile number and then using mobile number, like getting an OTP, or on email getting an OTP. So basic authentication every system is having, not that issue. But now the issue comes is like no authorization. Authorization and authentication, the difference is basically authentication means I am giving my credentials and I am validating like, hey, I am part of this particular system. For example, I am having let's say an account in HDFC Bank. So for me to use their net banking services, I need to provide username and password for entering into that particular net banking portal. So that is an authentication. Like, okay, I am authenticated user, I am an authenticated customer of this particular entity. But authorization means like, okay, what roles I am having, and as under the scope of my roles, what all features I can use or I can access. For example, once I am logged into a net banking system, what my roles are basically, I can go ahead and I can perform any transactions on my bank account, I can view my transactions. But if I request like, hey, I want to view the bank balance of some XYZ person, is it like under my role? No. Am I authorized to look anyone else's bank balance or perform banking transactions on behalf of someone else? No. That is, I am not authorized to do that particular operation. I am just authorized to do my job. That is what authorization is. And trust me, 90 to 95% companies out there do not have authorization mechanism. Basically, authorization you need to understand is like we have to protect that particular data. We have to protect that particular feature which is going to modify that data based on the roles a person is having. 90 to 95% company till date do not have this authorization feature. Then third thing is no rate limiting and throttling. So I would be having a dedicated video on rate limiting and throttling. Already I have a shot on that, but rate limiting and throttling is very much important at an infra level to protect your infrastructure. Why? Because now let's say a brute force attack is happening or someone is spamming you continuously by giving too many requests. Now in this case, if let's say my service is there, a single pod is deployed which can handle let's say 500 requests per second. Now in that case, if I am getting overburdened with like let's say 1000 or 2000 requests, now there can be multiple intentions. Some intentions can be like to bring down the complete system, so that like other customers should face hurdles. I want to break the password by applying let's say some brute force algorithm. In the brute force, okay, we just try to break that password by trying different combinations. So that many number of times we are hitting that particular request. So now again that is a problem. Like he wants to hack your system, he wants to get an unauthorized access. That's the reason he's trying. So basically like too many number of requests someone is sending you. It can be bot also, they are sending you, your system can't hold it. Now if they do not have rate limiting and throttling, the thing is like either the password can be cracked or else the system can go down. Fourth is no input validation. I have seen a lot of developers in my team, in other different teams as well. What exactly is done is like, okay, as soon as we get the data, we take the data and we directly dump into the database. So there is a difference between DTO and entity. When we get a request, that is considered as a DTO. When we dump it in the database, it is considered as an entity. So that data, that DTO needs to be validated, but we do not validate that. Because of that, what problem happens is SQL injection kind of thing that happens, where I'm directly taking that data and applying it at my database level in my SQL query. And now there is a chance like my database data can get corrupted. Or it is not only from an input validation perspective, but from an output validation as well. Like, okay, I generally take my entity, and as a response to the get call, I directly send. Now the database now the entity that we are preserving in our database has a lot of secure information. It can have a password, your banking account information, your account number, your personal, your demographic information, which needs to be protected. But we generally do not consider that. We take that entity and we just throw it as it is. That is again a big problem that many companies are doing today. Then no encryption of data in storage or transit. Like not all data needs to be encrypted, but the important data, the secure information, let's say your bank account number, your financial information, your passwords, all this information needs to be encrypted, but we do not encrypt the data. And generally what happens is like, as I said, in an output validation, the developer generally return the data as it is. So now because the data is not encrypted, the data as it is sent to the consumer. If someone is spoofing the data, that is the data in transit, then they can easily have access to it. Plus most of the time it happens is like without even thinking, we generally log the data, and in the logger file generally all this data is visible. So encryption, we try to protect the data, but no one is encrypting the data today while storing it or while in transit. Then comes the credentials hard coding. Credentials can be like say a private key using which you are generating your access token, or there can be any such security information. The keys generally are there which we are using for setting up our infra, which we are using for setting up our applications. All those secure keys are there. That generally what happens is like developers is free fall writing it into the source code, and now anyone who's having access to that source code have access to that particular key. They can manipulate that key and whatnot can happen. So generally we do not hard code the credentials anywhere. We keep the data in some secure places and then we access the data from there. And then the final thing is no audit trail. As a system, we have to ensure like our system is compliant with the rules of a land that we are operating in, plus the data that we are collecting. Let's say I'm operating it in India. I need to follow the rules and regulations of the Indian government. How am I going to protect the data? Plus if I am having, let's say, accessing the data of European people, then I need to follow the GDPR policy. Or if I'm accessing the data of US users, then I need to follow the HIPAA policy. Again, like what kind of an application I'm building, again it matters on that. So we have to be compliant. Plus whatever operation is happening, there has to be an audit trail. Audit trail can be like, okay, if any developer is having access to the production system, he's going and he's performing any kind of an activity. Do we have an audit trail? No. Today no one is having that. Because of that, someone can go and someone can blow up your data and you do not even track that basically. So that audit trail is again important. Till now, we have covered 3 agendas. What to protect, why we need to protect, and finally mistakes we are making it. Now finally we would be going on how to protect. So till now, if you have been on this video, you feel like, okay, this was something which is new, I was not knowing till now. So then please do consider liking this particular video, commenting if you have any query, any suggestions, sharing this video as much as possible, and subscribing to this channel. So let's go now to the final topic in our agenda, how to protect it. So now this is how we need to protect. Starting with authentication and authorization, the very first security layer of yours. Even though we have that username and password thing, but now that is outdated, that is old concept. Like majority of the systems are still using that, but that is like just one layer. When customer is trying to log in into your system, again at a customer level, there can be multiple things like OTP validation is there, single sign-on is there, or logging with your social network account is there. Again, there are multiple authentication and authorization protocols are there. Plus again, like system to system communication or direct hitting an API. So we can use Authentication 2, OpenID Connect, and RBAC, which is like role-based access control basically. So this authentication where like in a token only I'm burning inside the claims, okay, like okay, this particular person is having this particular access to the system, to the data. All those things are there that we are burning. Or to OpenID Connect, RBAC can be the latest new technological trending things in the market at a security perspective that we should be using. Plus we should try to adopt more and more latest advanced features. Let's say biometric authentication happens, or else like I said, authenticating using your Facebook or your Gmail account. The data security layer, the important thing is we need to protect, as I mentioned, the data needs to be protected in transit as well as when it is storage. So encryption is an important layer. So AES encryption we can use. So AES encryption, DS encryption, MD5, SHA algorithm. So all these things are considered to be a more secure algorithms that we can use when we are storing the data in a database. Checksum is something that we can use. Checksum is nothing but okay, when I am sending the data, at that time what I am doing is like I am compiling the data and generating hash of that data. That is, let's say, your checksum. Now when I am sending it to the server, let's say someone hacked your data or spoof your data, and they have changed the username or your first name or whatever your data is there, and now they have generated that. But now when they are sending it to the server, what server will do is like server is having a public key and a private key. So based on the data that he is receiving, the server is receiving, it is again trying to generate the hash, and now it tries to compare both the hash that it is receiving it in the request plus the hash that it has generated. If the hash matches, it means like the data is not spoofed or not changed in between. If no, then the data is changed in between. So now you might be thinking, if someone is hacking the data, why he can't change the checksum? He can't change that because checksum is generated using some private key, and not everyone is having access to the private key. Only the systems, the servers and the client applications is having access to that. And because of that, even if the hacker is hacking your data, he is changing it, but because you do not have that particular key, he can't change the checksum. And at the server side, because the data is mutated, if the data is modified, the server declines that request. So checksum is again like one thing that we can use. Again, HTTPS is used, which is like by default encrypting your data when it is getting transited. For that you need to have that SSL handshake and certificate and all those things. But TLS, which is like a transport layer security, in which again when the data is getting transited at the transport layer, the data is secured and encrypted by default. So again we can use that. Then comes the application security. In this the code should be going through a proper tool. Like say there is a check marks or different tools are there which does the validation of a security, where it checks like okay, whether the input is validated, whether the output is validated, whether you are not sharing any credentials, you are not exposing any sensitive data, or whether this can be a security vulnerability. So all the security check is firstly happening before your code is even getting pushed into the production servers. Plus the input output validations, the rate limiting, all these things are there that we need to ensure like okay, my application is secured by doing all those things. Then at an infrastructure level, we need to have a firewall that we are using. It can be WPA firewalls that we are using. Then OS security patches. Most of the times I have seen like the financial tech companies, generally what they happen is like okay, when they are deploying it, no matter you are deploying it on pod, on EC2, everyone requires an OS for it to run, right? So now that OS is having vulnerabilities. So every time the companies are coming up with the patches, the host companies are coming up with the OS patches, and it is the responsibility of the clients as in like me using Linux, let's say. So I'm having a company but I'm using Linux, so I should have that security patch, OS security patch applied. So and continuously updating my system to the new latest version, so that like my system is safe, because every time there is a security loophole, someone is identifying, someone is fixing that, and I need to ensure like that patch is applied on my system, so that like there shouldn't be any loophole or porthole where someone can enter in my system. Then again, like vaults, like I mentioned, credentials shouldn't be hard coded. So there are vaults, the cloud service is providing you the vaults where you can securely save your credentials. Network security, we need to use, as I mentioned, TLS, HTTPS. At a network security, VPNs, we need to use private public subnets, we need to define separately. These are all like at a network level, we need to provide the protection. Then logging and auditing. In this logging and auditing, whatever user activities are doing in the production servers, we need to log this user at this time has performed this operation in this particular system. Then finally, the regulatory compliance, as I mentioned, GDPR, HIPAA, then data backup, data deletion, all these things. Like a government is setting certain rules and regulations for the company, like, hey, your data should be kept in this format, in this particular storage format. If the customer is leaving your system, then your data should be deleted in so much amount of time. All those things are there, which every government is having rules and regulations, and you as a system, you need to respect that rules of that particular land and ensure like your system is compliant enough. So that's it about the security part. I hope I was able to contribute something to your knowledge. If you feel genuinely I have added some valuable information in your arsenal, so then please do liking this video, comment if you have any query, any suggestion, share this video as much as possible, and please do consider subscribing my channel. Thanks.